Today we'll be discussing a really simple experiment, which is one that I've personally had really good fun doing in the lab. That is the black box experiment. So our job here is to basically identify which terminal of the black box is which element in the circuit. And once we're done with that, we can find the values of each of the resistance or reactance of the components simply by using Ohm's law, which is a very fun. Now our black box has a resistor, an inductor and a capacitor which are connected at random inside each black box, and we don't really know until we do the experiment. That's the beauty of it. So to find the values of the resistances or reactance, we have three formulas that we're using. The first one is simple Ohm's law, R equals V by I, which we use to find the DC resistance values. And then we have capacitive reactance, which is Xc, and we can find it from the formula C equals 1 by 2 pi F Xc. And then we have the inductive reactance, which we can find using the formula L equals XL by 2 pi F, where Xc and XL are the reactance of the capacitor and the inductor.
Okay, so here we have our black box, and this is the milliammeter, and this is the
Regulated battery.
Battery, yeah. So then, what we have to do in the first step is that we have to identify the different branches of the black box. So we need to know the three components positions. So in this diagram, we have the resistor, inductor, and capacitor. But the thing is, in our black box, it could be in any order, right? So we need to figure out the order, and for that, we have to set up a very simple circuit. So what we have to do is we connect a battery eliminator to a black box and an ammeter, and based on the values of current, you can figure out which branch is which. So when you're connecting it, you start with the positive of the battery, and that connects to any one of the terminals of the black box. Then you connect another terminal of the black box to the positive of the ammeter. Then the negative of the ammeter comes back to the negative of the battery. It's a really simple circuit, and these are variable, so you can change the position of each of these and you can see the values of current changing. So now what we have to do is you have 6 possible combinations, right? So we have to any three of these will have zero output of current. So that will tell you that because this is a DC circuit, right? So the battery is DC, and I've set both the ammeter to DC as well. So in DC current, capacitor blocks the flow of current, right? So the current value will be zero. So three of these branches will have zero as the current, and that the common number for them. So when I did the experiment, it was 1, right? But when we do it now, I'll set it to 2, and you can see that 2, 3, 2, 4 and 2, 1 have zero output of current. So that means that our capacitor is at 2, like the branch 2 is the only capacitor terminal, and now we have to figure out which one is the inductor and which one is the resistor. Start with 1 and 4, and you can see that it's 79.80 approximately 80.3. Okay, so this is 1 and 4. Then we have 1 and 3, which is around 11 point something, and 1 and 2 will be 0, of course, and then you have 3 and 4, which will be similar to 1 and 3. So now the point here is that the one with the maximum current value will be the inductor, whereas the one with slightly less, and you can figure out by this point which one is the common terminal and which one is the resistor. Okay, now for the second part, we have to find the value of the resistance, right? So this is the table for that. It's very simple. It's just Ohm's law. Okay, so you know that according to Ohm's law, R is equal to V by I, or V is equal to IR. So what you have to do is, for the same circuit we had before, connect a voltmeter in parallel to the black box. Okay, so you can just connect two wires and put it parallelly, and you have to start with. So what you have to do is, as you vary the voltage, you have to note the change in the current values. So we start with 2 volts on the DC current generator. So this circuit will also be in DC because Ohm's law is for DC circuits. So we start with 2 volts, and for 2 volts you note down the readings of the voltmeter and the ammeter in the table. Then you just change the voltage in the battery to 4, and again note it down. then 6, then 8, 10, and 12. And once you get the values, you have to basically use Ohm's law to calculate resistance. Another important thing is that you have to make sure it was connected to the resistor branch of the circuit. So 3, 4 was our resistor, so I've connected it to 3, 4 while finding the resistor. Okay, so now we have to find the same thing but using an AC circuit. So we changed the the ammeter to 2000 milliamps because we need a different range of current values. Now the pins will still be at 3 and 4 because it's the resistor, whereas your power supply will be an AC power supply. So one of them will be fixed and the other one you can vary by changing the pin from 2, 4, 6, 8, 10 and 12 volts. So you have to follow the same procedure except you change the voltage differently, and you can find voltage and current values to find the resistance values, and this will be your mean R, which should be matching to the previous one which we found using DC more or less. So now the third step is to find the inductive reactance. So inductive reactance is basically resistance offered by the inductor. For that you have to connect the inductor to the circuit, and our inductor was 1 to 4. So when you change that, you'll see that the values are changing, and the same procedure will be followed except that when you find the voltage and current for different 2 to 12 volts range, you can find the resistance values, but that will be XL now. So XL, you have a formula to find L from XL's formula. So using this, you'll be able to calculate the inductance value once you find mean XL. One thing is that we were using a 200 milliamps ammeter, but this time the range will not be enough. So we have to use a 2000 milliamps ammeter for better balance. And for the last step, we are finding the capacitive reactance, right? So the capacitive reactance will be really high. So for that, your current values will be kind of small. So for that, you have to be using a 20 milliamps ammeter instead of 200. So continue. So now I switched it out, and this is the 20 milliamps ammeter. And since we're using the capacitor, I'm going to change this as well. So we're going to use 2 and 4 because that's the capacitor in our circuit. So the same procedure again, you have to change voltage to change the current values and note down the voltmeter and ammeter readings. Using that, you can find XC using Ohm's law. And when you do that, you can find mean XC, and using mean XC you can find capacitance using this formula.